Hey, what's going on, guys? Mega Games here. A quick update on Bitboard CHESS ENGINE and C development. So, as I have been mentioning in the previous video, I'm gonna take the time handling implementation from Wise Chess Engine, written by Richard Allbert, also known as BluefeverSoftware. So, instead of retyping this and torturing you to make you watch this, I would rather just quickly walk through the updates within the source code and put the references to the original tutorials on parse go command and some well, actually UCI in general, and also I will try to find all those videos from the Vice series where where Richard actually did add all of those time handling functions to so you can actually see like how it has to be done, because I won't really do this better than he did, and I just want to focus on the code that I'm writing on my own, and if I'm reusing someone else's code, I would better just put some references, some links in the description below this video, and that's it. So let's quickly walk through the source code and the updates. So first, we did include an extra header, uni.std.h. Then we have, well, the difference is as expected between BBC and Wise. Then in BBC here we have the global variables for the time handling. So hope the commentaries are self-explanatory here. So Wise did have this within the search info structure, while here we just use the global variables straight ahead. Some miscellaneous functions work from Wise again. Well, actually I put the get time in milliseconds here because it's necessarily needed, assuming the one file project layout. And even though I did type this myself, I did completely take this from Wise as well, so just it's the right place for this function. A function input waiting that is operating system dependent and serves the purpose of listening to the user input during the search. Not exactly sure how it works, so didn't bring any commentaries here, but this is the function that Richard has forked from somewhere himself. I don't even remember where exactly from he did it. Then read input is the helper function that actually just tracks whether the quit or stop command has occurred from the GUI, so just to respectively to exit, to terminate the execution of the engine, or just to stop calculating. That's kind of it. Anyway, actually both, regardless of the command, the result is the same. We just terminate the execution. Yeah, so it's not the time's up, sorry. So time's up here, so if the time in millisecond currently is greater than the stop time, so in this case we just stop calculating, and that's it. So this wait communicate function is the function that in Wise it's called checkup, but I decided to call it communicate because it's literally what it does. It does allow a search function to communicate with the input from the GUI. That's the reason why I call this kind of communicate. So let's move further on. Nothing new here until the search currently. So let me just go to the search. So here within the search, okay, yeah. So starting from the quiescence. So at the very beginning, every 2047 nodes, we call this communicate function to make sure that if there is a stop command or quit command from the GUI, we just stop calculating. That's kind of it. So remember, like, you can click a button within the Arena GUI, forcing Engine to return the best move so far he has. That's how it's done. Basically, that's the hook from that's the hook within the quiescence, and the same stuff would be within is already done within the Nigamex. So that's the hook allowing us to actually tell the deep recursion to go back and to give a best move so far it has on the current depth. Another thing, so it's done here. Okay, and within the Nigimax it's done right over in here, and yeah, also this stopped true, so if stopped equals to true, which means that if time is up, then we just return 0 and we just stop calculating. And this stopped has to be, did I miss it somewhere? Let me just reference. So here we have okay, so this if stopped true just right after the take back function. Then the same is within the null move pruning, which is important, and the same after the take back within the Nigimax search, right here within the Nigimax search. And then within the search position, so every time we're starting searching for a position, we reset this flag back to 0, otherwise we won't be able to calculate. Okay, so among the other initializations, okay, what else? Iterative deepening. So if stopped is equal to true is also available within the iterative deepening, which means to return the best move so far from the depth that has been occurred already. And if we're now trying to search even deeper and the time is up, we just drop that search and return what we have already. That's kind of the idea, and this is it basically. So yeah, also just added some commentaries within the UCI section to give a credit to Richard Allbert. So parse move, yeah, nothing, no changes here, and parse position, no changes. Here, parse go, so here we have the changes. So apart from only matching the UCI depth command and parsing the search depth respectively, we're adding all the time controls available. So infinite search, increment for white and black, so like when we're playing blitz with some increment in time, like 5 plus 2, 3 plus 2, 5 plus 3, and so on. White time and black time command, if I'm not mistaken, it's used in blitz as well. Okay, moves to go is quite tricky, so for those tournament time controls like make 40 moves in 5 minutes or things like that, so this is where it comes around. So moves to go is the number of moves to make within the certain amount of time. So here we parse this and making use of this. Later on, move time is the mode when we can actually tell our engine to search for 3 seconds, search for 5 seconds, and then make move regardless of what depth did you reach. So just kind of move time. So this is handled here. Well, depth is a fixed depth that we've been covering before. And now if move time is not equals to -1, which means if the timing is actually available, we initialize the time to move time, initializing the moves to go to 1, then initializing the start time, just getting time in milliseconds at current moment, initializing the depth, and okay. I'm a bit concerned about this line, even though it works. Just looks a bit confusing. So I'll check this out as well. Time control is available. So yeah, if time control is available, we're setting the time control flag and setting up timing, dividing time by moves to go. So kind of two modes: when we have this moves to go or we don't have that, the stop time is calculated respectively. So moves to go might be 1 as well, so just some optimization. So you would better just watch the video by BlueFever, by Richard, where he actually explains all this stuff in great details. I didn't really went too much into it. I just made it work, and that's kind of it. And also some debugging information regarding what particular mode we're currently in. So that's kind of it. Okay, guys. So and the very last thing I would like to show you is actually how it works. So here is the latest version, the source code of which you've just seen on your screens. So let's start. So, well, I guess the fixed depth is quite pretty clear because we've been testing this already numerous times within this series. So just going for a fixed depth, this is quite pretty clear. So now let's go for engines, manage. Oh, sorry, not this. Levels adjust. So time per move. Well, let's give it 3 seconds per move and demonstrate. So here we have like 1, 2, 3, and it makes a move. 1, 2, 3, and it makes a move. Like 1, 2, 3, and it makes a move. So just every 3 seconds it just makes a move. That's it. And depth might vary because within the different positions we have a different amount of nodes, hence the time to calculate that might be different. So with the fixed time we not obviously have the fixed depth, so the depth might vary here. Okay, so I hope this is quite pretty clear. I know the position looks a bit weird because it has a very rudimentary evaluation function, which we're about to improve, obviously, but it's not the case now. We are talking actually about the time control. So now let's go in blitz. So let's give him like 5-minute blitz. Increments are working as well. You can try this. You can try this at home if you like. I just never use increments. I really like just the fixed amount of time, but the increments works as well, so you can check that out. Let's make the engine plane versus itself, and you see like it thinks like to go for a depth of 10 in blitz, which is quite pretty impressive. Well, depending on time, he would be changing this depth, and if we just see how it is playing versus itself, we'll see that the closer he goes to the end game, well, if he's losing time, if he is kind of losing on time, he might start reducing the depth. But if he's okay on the clock, and if he just like, you know, if there are not really so many pieces available, in that case he might increase the depth in the end game up to, well, let's say probably even 16 applies. That's the biggest number I had, and I'm just now seeing that well, I actually did remove one little line eventually implemented by Richard, and now I think that was a bad idea. So just to match the exact time when it comes to time per move, I did remove one little line which was subtracting 50 from the time. So it was like if it's 3 minutes, it's 3 seconds to move, it just took kind of 2 seconds and like almost 3 seconds. But well, okay, so I just see that I don't really like what I see here, so probably just bring it back to the original implementation. So now I see that what actually Richard did made a perfect sense. Okay, so anyway, so now he keeps the depth. So I just I don't know. So let's actually, so just to give you an idea of dynamic timings, I would probably go for, let's try a bullet game and see how it's supposed to be going in this case. So let's see. So the time is gonna it should start running out of time quite pretty quickly. So it starts with a depth 10, which is good, and the less time he would starting to have, the faster he is gonna be moving his pieces. Okay, so depth 9. Okay, well, this is a bit strange move, G7, G5, and this move is strange as well. Well, actually protecting the knight, But again, I just want to show you guys like the depth is gonna be changing along the way, because we're kind of running out of time. Well, at least it should really. Okay. Okay, go into the depth 8. Okay. Back to depth 9. Well, this is a little bit strange. Well, at least when I decided this versus DSCP, the depth was really dynamic. So, okay. Yeah, I'm just really wondering how is it going to behave in this case in particular. How is it going to behave here? So really down on the clock. Well, probably, well, I'm not really that sure much. Yeah, so just up on the clock. Well, okay, so anyway, as far as I'm not really sure how exactly this should be working, I can't tell you for sure, because I'm not really sure how exactly Wise is handling this. But I just but the idea is that, well, let's say I just want to give you this little example. So just set up a position, nope, and clear the board, and let's set some sort of an endgame here, like this, and white to move. Okay, and set levels, adjust. Yeah, let's have this 1 minute. So now it just should be going really deeper. So let's have a look how it's supposed to be playing. We'll still go in depth 10. Well, this is a bit strange because, okay, depth 12. Okay. This is a little bit strange. Okay, guys, so, well, probably let me just drop this. Yeah, he finds the mate, fortunately, but it's not the case. So I will probably bring this time minus equals 50 back. I'm not sure if this is gonna change that much, but I hope so. So let's make it again, and not really that sure how exactly this is gonna be. I'm sorry, how exactly this is gonna be changing the behavior of the engine. Yeah, I already feel like I shouldn't really change that because it seems like working nicely. So, well, let's try the same position again. I'm tempted to know myself basically whether it's well, it seems to be playing the same game. Probably he doesn't need more within this position, not sure. Okay, and I'm just wondering, what do we give Black resigns? Okay, I'm just wondering, what do we give levels adjust 5 minutes to this position? So he should actually go deeper in this case. By the way, if we just force him to go, you see, like, we can force engine to go like this, but let's try to find Well, okay, let me just so one more test. I'm not really sure, but just set up the position. So let's put it a bit different endgame. So like this and like this, and let's enjoy the show. So I was supposed to be playing this. Which kind? What depth is this gonna hit? Really wondering, because I swear I saw the games like BBC was playing versus TSCP and okay, depth 18. Can you see this, guys? He now goes to the depth 18. So he just didn't need to go deeper in that case, probably depth 19. So you see, like in this endgame, he goes really deeply. I'm not sure though whether this is because I added this line or not, but this is really getting interesting now. Like a very deep calculation within the end game, which is really nice thing to consider. So takes. This is interesting. So it seems like a draw here. I'm not an expert in endgame, so it's hard to tell. It's hard to say from the human perspective how is it going, but probably it should be a draw basically. So white takes. So this pawn is not going anywhere, and this pawn is not going anywhere as well. But what I wanted to show you, this the depth is increasing dramatically in the end game. So that's quite pretty important thing to consider, because we really do have kind of lots of time here. So just to bear in mind, if you have kind of lots of time and not really that much pieces, then we actually it seems like no, it has to be a draw. It really has to be, because king takes and yeah, just king takes and this is a draw. Yeah, but the depth 26 eventually, which is fascinating really. Okay, and taking the pawn and the draw. Okay. Well, no, this is really interesting. Well, probably because he doesn't know about the drawing material. Probably that's the reason. Also, threefold repetition is not yet being covered, so yeah, well, anyway, just insufficient material. So because BBC has no idea regarding the insufficient material evaluation at the moment, that's the reason why he didn't take this pawn immediately. Okay. Well, okay guys, so this is it from my side. I would now update the GitHub repo with this initial, so I just dropped back to initial implementation by Richard Allbert. Well, if somebody knows exactly how this time minus equals 50 might benefit the engine, please let me know in the commentaries. I'm really interested to know that. And yeah, this is it. This is basically it. So a few words regarding the next steps. I've been testing BBC versus TSCP, and at the moment, even though it plays kind of several plies deeper, it draws all the games versus TSCP. And what is even more depressing is that he may be a rook up, and still he goes for a threefold repetition, because he has no idea regarding threefold repetitions at the moment. And also, one of my subscribers also mailed me a game where BBC was playing versus I don't remember the engine's name. I need to pick that up. And that was the same situation. So the kind of engine was material up, but went for a threefold repetition, and that was a draw. Well, that was a complete win basically. So the very first thing to cover is actually to get rid of this threefold repetitions. So in order to do this, we need to keep track of position keys that would be achieved using the so-called Zobrist keys that I'm supposed to be implementing, and those videos would be kind of full-blown tutorials when I would be writing code from scratch, well, like regarding Zobrist keys. initializations and regarding the incremental updates of those arborist keys as well. And usually people do this within the make move function, but I promised you guys not to touch the move generator code while writing something related to search, so we would be incrementally updating our arborist keys within the search itself, apart from the make move function. So that's the first idea. Then the second idea, as soon as we will have our arborist keys, it would be, I don't want to say this would be trivial, but this would be quite pretty easy to implement the very basic transposition table that which implementation I would be referencing from Bruce Moreland's site. It has a very cute, nice, and easy to understand implementation. That would be the very first transposition table in my life, so I would be learning just like you guys, and really tempted to see how it's going. And then probably, well, most likely, I would be checking for the threefold repetitions using that transposition table, not like it's done within Vice or TSCP where they use the so-called history plies array, but instead just trying to retrieve those repetitions from the transposition table. At this moment I have no idea how that is done, so probably I will need to ask a couple of dumb questions on Talk Chess, but anyway, I really want to do that, so we will eventually have a completed search, well, at least regarding the very first initial release of BBC. And when we have the search being completed, we will then go to implementing some very basic things regarding the evaluation. So we will implement the pawn structure evaluation, like blocking pawns, passed pawns, double pawns, semi-open files for the rogues, things like that. And then some very basic key safety is about to be implemented as well. And I hope to see the dramatic growth of elo rating in that case, because it's really depressing to see like if BBC is playing like several plies deeper compared to TSCP, but it draws all the games, because TSCP is basing on the ratings from CCRL. The current the TSCP's rating, I'm not sure regarding the time control, but its rating is 1653, which means that BBC's current rating is about the same because it draws all the games versus TSCP. So that's kind of it. And even though sometimes the search is twice deeper and even 3 times deeper when it comes to the endgame, it still doesn't help. It doesn't help it much. So the very basic evaluation in TSCP gives it a compensation for being for being slow within a search. So I really hope that as far as we'll have a decent evaluation function, well, at least somewhat better than we have now. In that case, the playing strength of this engine should get increased. Really, should really get increased, and then we'll obviously try some stronger opponents likewise. This only my dreams at the moment, but we'll see what we would be able to do together, guys. So I really appreciate you watching this series and following the tutorials. Hope to see you in the next parts. Until that time, and take care.